To understand Docker, imagine you have built a web app using Node.js version 17, React version 18, Express, and a few other libraries. It runs perfectly on your computer. However, when you try to set up the same environment on another machine, whether it's your friend's laptop or a server, the app refuses to work no matter how long you spend troubleshooting. This problem often arises from small but crucial differences like missing dependencies or version mismatch. It's frustrating, time consuming, and something every developer has experienced. This is where Docker becomes a game changer. It simplifies the entire process by creating a standard environment for your app. To do this, Docker uses something called an image, which acts as a blueprint. This image contains all the instructions needed to set up your app's environment, including the required dependencies, libraries, and system configurations. Once you have this image, you can share it with anyone. When the image is executed, it creates a container, a live running instance of your app. This container behaves exactly like your development environment, ensuring that your app runs smoothly on any machine without the need for manual setup. To create an image, you can write a Docker file. This Docker file is essentially a script that outlines how to build your app's environment. It specifies things like the base image, for example, Node.js, the libraries to install, and the commands to copy your app's code and start the application. With a single command, Docker takes this Docker file and generates an image for you. When the image is run, it spins up a container. Containers are lightweight and isolated environments, which means they don't interfere with your system and can be easily started, stopped, or even deleted. This makes them incredibly flexible for testing, debugging, and deployment. One key thing to keep in mind is data. Containers are designed to be disposable, which means any data stored inside them is lost when the container stops. To handle this, Docker uses volumes, which store data outside the container, so it persists even if the container is removed. This is especially useful for things like database or user upload files. For projects that involve multiple services like front-end, back-end, and databases, managing individual containers can quickly become overwhelming. That's where Docker Compose comes in. Using a simple YAML file, you can define all your services, their configurations, and how they interact. With one command, Docker Compose sets up and runs everything, making multi-containers app much easier to manage. Once your app is containerized, deployment becomes a breeze. Whether you are running the app on the local machine, a testing server, or a cloud, it behaves exactly the same. You can even use Docker Hub to share your images or access pre-built ones for popular technologies like MySQL, Redis, or Nginx. As your app grows, Docker scales with you. By integrating with orchestration tools like Kubernetes, you can manage multiple containers, balance workloads, and ensure high availability even during peak traffic.